Before I start, I just wanted to announce that there is an effort ongoing for a professional declaration of architectural independence, architectural declaration of professional independence. The knowledge bases that we traditionalists use are different from those that are used by what is in standard practice called architecture and planning and urbanism. And I think that in the name of diversity of our knowledge bases versus the others, that our knowledge bases actually create a specialty. And they create a specialty in traditional architecture, specialty, classic planning, and manual skilled trades in construction, the building arts. So we're forming a document to prepare the basis for this. We are working towards accreditation on the academic side, and we are going to have here an extra mural working group on this. You can join it on a WhatsApp. I think it's a declaration working group. There are 3 people here already have the QR code. You want to stand up and just show yourselves? These 3 people have the QR codes: Carl Korsnes, Allison Hogg, Pablo Funes, and you can approach them or myself to add on to this group. We will have discussions during the BUA and then meet to maybe confirm or take it to the next level. And you see here some of the ideas that are in this declaration. So our charter, it's actually our legal charter, is to steward the knowledge bases of the classical method through practice, teaching, and community engagement, and this is part of our community engagement. We're a very, very small nonprofit. We plow all our proceeds back into the work. And we hold this particular conference as being of particular significance, and we're committed to helping bringing it to the world as a whole. So here we go. We're going to be talking about the introduction to architectural literacy. Architectural literacy is not knowing every single building that was ever built. Architectural literacy is actually being able to read the built environment. It's much like you don't need to know Shakespeare to read a newspaper. It might help, but that's a different story. Architectural literacy is actually based on a small set of forms that you'll see in a moment. It's simpler than reading literacy. It has less bits to it than music literacy. Fundamentally, it has 3 types of stuff. You have what I call the triads, like everything has 3 parts, everything comes in 3 sizes, and so on. The elements: moldings, orders, columns, entablature, doors, windows, and other elements. I want to impress on you how simple, logical, usable this system actually is. Not to say that there's a huge amount of richness, and we're going to tap into some of it looking at this room. And then there are the tools, how to put all this stuff together, entasis, intercolumniation, and so on. I learned this mostly from Calder Loth, but my other great teachers are Steve Bassey, Seth Ween, Christine Frank, who was my best design teacher, Richard Cameron, who knows everything, Marty Brandwine, Ann Fairfax, Alvin Holm, and Richard Sammons, who actually sort of gave me the lever to penetrate all this stuff. Oh, look at that. They have a screen down here. So the thrust of all this is that it's a communication tool. It's such a powerful communication tool that it can help engage in a meaningful conversation regarding the built environment. So everything is made of 3 parts. Everything has a top, a middle, and a bottom, a left, a middle, and a right, a back, a middle, and a front. That's very, very important. I can start explaining you how this fits into some kind of a neuroaesthetic model of how we capture the environment. And most of these things really come from a brain processing standpoint. These are what I'm talking about, is the effects of how the brain processes the environment. And the brain learned to do this in the African savanna. So we're providing that brain with stuff, whatever it is, like this. And when you look at this, you immediately see that everything's has 3 parts. And the 3 parts, they're divided into 3 parts, and those parts are divided into 3 parts. It just is part of that thing. So this is like literacy. This is what the letter A looks like. There's no A that looks like a Z, for example. Everything comes in 3 sizes: small, medium, and large. There it is, small, medium, and large. Everything's you got going on in there. There are only 3 ways to connect rooms. Most architects would think that there's an infinite number of ways to connect rooms. There isn't. There's just 3. Room to room, room within a room, and then rooms to another room, whatever it is, often a corridor. And you get this. It has 3 sizes of rooms that are connected 3 ways, and there's front, middle, and back every which way you go. Villa Rotunda, we all know it very well, one of the finest buildings, and there's a nod here to, am I getting this? Ooh, look at that. I don't know what it's showing. The people on top of the pediment, the eye, or the eye brain, actually identifies a building like this in 80 milliseconds. It identifies a human in 80 milliseconds. That's the way it is. That's the way it's all set up. There's a very quick identification, not only of humans, but of human-made things in the way we have our consciousness structured. Those individuals on top, those sculptures on top, force the eye to see the whole pediment and thereby the whole building. So Palladio, who was a fairly good architect, he knew this and he applied it. All of the stuff is made fundamentally out of 8 shapes. And there are subshapes on all of these. But basically, it's like the difference between an F and an F sharp and F flat. Very, very important, but for our purposes, it's still an F. We have the fascia, which is a large flat, a fillet, a small flat thing, ovalo, which is a convex quarter circle, cavetto, convex, a concave quarter circle, a convex half circle, and you can see that these can be extruded either linearly or radially. Torus, a scotia, the half circle extruded. And then we have cyma recta and cyma reversa. So you got the cyma recta has a horizontal thrust, cyma reversa has a vertical thrust. Horizontal thrust is about shelter, and the vertical thrust is about support. What else do you need in order to understand the built environment? Just a few more things. All these things come from there. So, all these moldings, they are analogous to alphabetical letters in the orders, and I want you to look here around the room. By the time we're done, we should be able to read the room. You can see here that if you took the, let's say you took the volutes and you put them over here, it wouldn't make any sense. But it goes into a finer grain as well. If you changed the order of these moldings in the order, it would lose its, it would not be comprehended in the same manner. And this sequence is immutable. It's not that the actual form is immutable, it's the sequence that is immutable. And generally, moldings come together with changes in materials or changes in planes, places where we need to hide the shame, so to speak, or elaborate. We can elaborate them. And you can see that wherever we have elaborations, they're actually a very simple shape. For example, the ovalo that makes up the egg and dart pattern, you have it up here in these. The orders, if we call actually the letters these are these are the words that make it up, the moldings. Then the orders are the grammars. Each one is a different style. Doric, Ionic, Corinthian. I think everybody's familiar with these. We look at them as the style. We talk about the language of architecture. I don't know that there is a language of architecture, actually, if you want to make this kind of analogy, but I think you understand where we're going. And the orders are the grammar. You know that Tuscan is simple. You know that the Doric is strong, bold, masculine. You know that Ionic is feminine and beautiful. Corinthian is fancy. Fundamentally, the world has male, female, and fancy. And then it's got the composite. Make of it what you will. This is how fundamentally, generally, we look at the world. We're not saying closing the door on any other possibilities. But the orders, they set form over the necessities of shelter. They're the visible evidence of a building's ascent to architecture and establish its role as civic art, also by Palladio. I really like his work, but the thing I like most about his work, and you have to see it, is not just the shapes and so on. Look at the details, the way he brings a brick to marble, the way he carves the materials, and I don't know, his stucco work is probably the best ever, and so on. You really need to look at it. Columns. Well, we have round columns, but columns are posts, okay? The whole damn thing up, or they look like they do. And the difference is really not of no consequence. Columns are round, and piers are rectangular, and pilasters are rectangular columns engaged to the wall. So these are pilasters, 1, 2, 3, 4. There are columns that are engaged to walls, like pilasters are, but they're called engaged columns. Okay, whatever. And we have pedestals, which are absent here. But the pedestals, actually, they're a little elastic, so you can adjust to a slope. You can use them to accommodate whatever other issues show up to a certain degree. Entasis, hugely important. And this is where the neuroscience comes back big time. In order to make a column appear straight, you remember that the lens of the eye is conical. If you look like this out of the side of the eye, things curve this way. You look at it, the eye on this side, they curve that way. It's very hard to see a straight vertical line. In order to make things appear straight, they are tapered towards the top. They're made smaller in order to accommodate the conical lens in the eye. The convention is 1/6 the diameter at the base. And if you're going to do it 1/6 or some fraction close to it, it's really your call as an architect, depending on the circumstances. But you understand that the larger the building is, how things change in order to accommodate the size. The entablature has 3 parts, and we can see it here very, very clearly. Entablature is what sits on top of the column, and you'll see here that it has 3 parts: architrave, frieze, and cornice. Architrave is the main beam. Look behind over here. You have the full. Well, actually, you don't. It's yet again, because they're playing games. You know, they did this on purpose. They knew I was going to talk about this, and they changed everything. So we'll read it from here, and then we'll look at that and understand what they did here. So we have the architrave, the frieze, the cornice. Architrave has basically its flat surfaces, in this case 2 of them, and then a band called a tinea, which is named for the headband of the athletes, and then you have a frieze, which is named for the Frisian band that the women of Frisia used to embroider, and that's where you put your lettering and your carving if you need to express whatever. And then you have a cornice, which is a set of stepped architectural events, moldings that you can't change the order of them, which actually protect the wall from the water and give you the crown of the building. What happened over here is that if you look, let's look at the frieze, the flat bit in the middle. We identify that easily. Then we have the beads running around at the bottom of it. That is the tinea of the architrave. And then you look and you have the carved bit that's right under the tinea, and then a flat bit. That flat bit is the bottom of the architrave that slipped down behind the top of the column. I don't know if it's intentional or if that was the result. It looks like much of this room was drawn by someone who intentionally fooled around with it. But it looks nice and it is comfortable, and you see that the cornice and so on and so forth does have a reference to many of these steps that go up. I can't see. I can't see, it's black. Oh, 10? Well, that's a long time. I thought I'd, be in and out. I need to tell you something that the first time I heard it, it really, shocked me. Doors and windows are always supposed to be the same proportion, 1 to 2. And you can play a little game. You can make them a little taller. You put the point of the compass over here and the pencil on that corner over here, and you run it up, and you'll get to that higher thing. So it comes from all architecture. It comes from straight edge and compass. You don't need anything other than that in order to draw anything, ever. So there it is. Once you're using these tools, you can, go as far as you want and however you want. One of the most interesting things about how doors and windows work is that basically you got a hole in the wall, okay? So if you don't have something supporting it, the wall is going to fall down through the door. So you put an architrave there. You put that beam up there. And then you complete the entablature. In order to get a door frame, what we call colloquially, you actually take the architrave and stretch it around the sides. So that's a door frame. Once you know that, you're halfway towards some kind of higher level understanding of all this stuff. And then you have your frieze. And we see here that, the door over there is rather simple. It's just cut in the wall. This is a 1920s interior, or 30s maybe, I assume. Correct me if I'm wrong. And then you have the cornice. Well, the cornice can be expressed either as a gable, can be stretched up to be a gable, and the triangular one, or it can be arched like this. So you have several different options with regard to treating these. You don't have a hell of a lot more. You do have a broken pediment, which is a Roman notion. I suppose that at some point someone started building it and didn't finish, said, oh, that looks pretty good. And they stuck with it. So you have different types of gables that you can work with, of pediments that you can work with. Naturally, you have the whole business of arches. I'm not going to go into that right now. They're fascinating and really enriching in many, many cases. I find the balustrades the most interesting part in that everything we do, designing architecture, buildings, we do the proportionally. We design proportionally, not from dimensions. Well, yeah, it's got to fit on the lot, and people got to be able to walk through a door, but beyond that, that doesn't take much to figure out. Everything is designed proportionally, except for the balustrades, which are railings, because you don't want one that is too high. It makes you look like a dwarf. You don't want one too low. You're going to fall off the damn building. So they are actually done for human height. And you have this stuff in the street, all of this stuff. All of a sudden, you know what you're looking at. The pediments over the windows, the arcuated ones, the triangular ones. You can see here that some of them don't have pediments at all. You see the rhythms occurring, et cetera, and you get basically the kind of rich environment that humans need in order to survive wherever they are. In some places, you get it through nature directly, where when we build, we have to provide an equal amount of richness for people to look good, even in a simple worker environment like this was when it was built. With everything we've heard until now, we actually can create all the compositional building blocks of buildings, and they tell the story. It's a narrative that they tell. The chimneys and the ceilings and the elevators and the terraces and the porch, it's what it is. And you do whatever you need to do in the context. Intercolumniation, it's, unless you're a technical architect, actually figuring out the rhythm of something, really don't need to know this, but we use the diameter at the base of the column as our module, and then we count one space, a space and a half, two spaces, 2.5 modules, and get whatever we need. And this follows up, in this case, the Doric, using the Doric order to show the different types of rhythms and the spacing out of columns that would work. And generally speaking, the tighter the columns are, it reflects that we're doing stone construction. The further apart they are, it's wood, and if they're very far apart, it's likely steel. Proportions. There are 8 types of proportions that are active at any moment in a design. The first 3 are essential. You have equality, which is bilateral symmetry. You have differentiation, large from small, and we generally use the golden section for that. And then there's punctuation, that's the tip of the leaf. It's the last bone in my finger. The first finger is in here. It's roughly between 1/5 and 1/7. We have other proportions, we can talk about that later, but what happens is that these proportions are repeated. They are repeated in the order at different scales. So you have self-similar patterns repeated at different scales. That is a fractal. So each one of the proportional systems, 8 of them, and you know already about 3, are fractals. And this is how it is processed in the brain, just like a tree is fractal. The leaves are fractal, the branches are fractal, the bark pattern is fractal. 3 fractals in a tree. Don't believe anybody who tells you that a tree has only 1 fractal, the branches. It simply shows how far advanced they are. A minimum of 3 fractals. When you're figuring all these things out, standing in front of a classical building, your brain does not know you're not looking at a tree. And it lights up the beauty center in the brain. The pleasure center is right here where the third eye is supposed to be. And we have a few more issues that I'm going to gloss over. One is sizing, just like we had entasis for making the columns narrower at the top. We also make the floors smaller by 1/6 as the building goes up. And you can see it here at the top of the building, how the floors are sequentially. I'm trying to get this thing to work. Oh, that's the wrong one. It doesn't work, okay. So you can see the windows getting sequentially smaller as you go up. Placement, Doric, Ionic, Corinthian. If you look at a traditional building, if it's multi-story and changes order, it'll be Doric, Ionic, Corinthian, but it also works inward. So you go from maybe in the foyer will be Doric, the hallways will be Ionic, the main chamber will be a higher order. In this building's case, the exterior, you can call it Doric. This is an Ionic room. Ionic is considered the most beautiful. That's why they chose this one. There's a matter of appropriateness. In other words, you don't need to always be, you're not putting one wedding cake next to another. It's not what we do. We create buildings that are appropriate to their role in the place. such as the Palace of Charles in Granada. And you can see different types of architecture, two on the outside, one on the inside. Imagine for yourself, you don't need me to explain to you what this actually reflects, and so on. Some of our own work, when we're trying to make something regionally appropriate, we're using regional proportions, in this case Mexican, to make something look Mexican. And then finally we have design by deletion, which is that you don't need to tell the whole story every single time. You can actually delete elements, and you can see how simple some of the arches are, some of the windows are. They're just holes in the wall. And yet the whole thing looks rich enough for what it is, which is apartments. We saw the elements, the threesomes, the bits, and the coming together elements, and this is how the experience of art imitates the experience of nature. We use these elements in doing our urban design, including some of our own work. We are conscious of all this all the time, that we are designing whatever work we're doing. We always go back to the proportions. We go back to the orders. We take the order, slap it on the building, run it up, and figure out how it responds in this. Why? It's a built-in multiple fractal pattern. What better thing do you want to use as a studio designer? We believe that architecture is central to urbanism. We work towards genuine holistic work. We believe in the balance of town and country, and the crafts are essential. Thank you very, very much. This has been a real honor to be here. Thank you.